Number one, the curve y equal a cosine bx plus c, where a, b, and c are integers, passes through the points minus pi over 6 and minus 2 and minus pi over 9 and 1/2. The curve has a period of 2 pi third. Find the values of a, b, and c. This graph or this curve has period is 2 pi over modulus b. Okay, and based on this information that the period is 2 pi third, so we can state that b equal 3. And after that, this curve is this one, where y equal a cosine 3x plus c. So it means plus c. So, and it's true based on this information, minus pi over 6 and minus 2. So we can substitute this information into this equation and it becomes minus 2 equal a cosine 3 because b equal 3. 3 times minus pi over 6 plus c. So it becomes minus 2 equal, this is cosine 1/2, cosine minus 1/2 pi. Cosine minus 1/2 pi is 0 plus c. So c equal minus 2. And this curve passing through this coordinate point, pi over 9 and 1/2. So if we substitute into this equation, it becomes 1/2 equal a cosine 3 times pi over 9 minus 2 because c equal minus 2. And it's going to be 1/2 equal cosine, this is 1/3, 1/3 pi. Cosine 1/3 pi is 1/2. 1/2 minus 2. 1/2, sorry, this is a actually. A times 1/2. So we can state that 1/2 a equal 1/2 plus 2, like this. So a equal 1/2, a equal 5/2. So a equal 5 because 5/2 times 2. So it means it means a equal 5, b equal 3, and c equal minus 2. Let's continue to the next question. Find the least value of y on the curve for x interval 0 to 5/2 to pi/2 and state the value of x at which this occurs. Okay. The function, if a equal 5, b equal 3, c equal minus 2, so the function becomes y equal 5 cosine 3x minus 2. This is the function. And y will be minimum, okay? Y will be minimum value when cosine 3x equal minus 1. On cosine graph or cosine curve, the maximum is 1 and the minimum is minus 1. So it means 3x equal pi based on this equation, this expression. Okay. So if 3x equal pi, so x equal pi third, like this. And about y? Y equal 5 times the minimum is minus 1, minus 2, and it is minus 7. So the minimum occurs at x equal pi third and y equal minus 7. Next question number 2. It is given that y equal fx. Fx equals 2x minus 5 times x minus 1 squared. Find the coordinates of the stationary points on the curve y equal fx. Right. To find the stationary points, we need to set the derivative equal 0. So we are going to find the derivative of this expression, this function. The derivative is really using the product rule. It becomes 2 times x minus 1 squared. Okay, derivative of 2x minus 1 minus 5 is 2 plus derivative of x minus 1 to x minus 5. The derivative is 2 times x minus 1 squared. That's the derivative. Okay, 2. So, uh, sorry, without, without square. And it equal 0. So it becomes 2x minus 1, x minus 1. Uh, I will writing 2 first. Okay. 2 in front, 2x minus 5, x minus 1 equal 0. And after that, factorize to x minus 1, to x minus 1, factorize x minus 1 plus 2x minus 5 equal 0. 2x minus 1, 3x minus 6 equal 0. So x equal 1 or x equal 2 because 6 divided by 3. And after that, substitute x equal 1 and x equal 2 into, substitute into fx, 2x minus 5, x minus 1 squared. So if this x equal 1, so it means f1 equal 2 times 1 minus 5, 1 minus 1 squared is 0. So the stationary point, is 1, 0. And if x equals 2, f2, 2 times 2 minus 5, 2 minus 1 squared. If you calculate this, the result is minus 1. And the stationary point is 2, minus 1. So there are two stationary points, 1, 0 and 2, minus 1. On this axis, sketch the graph of y equal fx, stating the intercepts with the axis. Okay. There is an information that the stationary point are, just now 1, 0 and 2, minus 1. So, if 1, 0 here, this is 1, 0. Okay. and 2 comma minus 1, 1, 2 here, minus 1 here. Yeah. This is So this is 1 comma 0, the first stationary point, and the second stationary point is 1. This is 2 comma minus 1. And after that, y-intercept. The y-intercept, I'm going to write it here, y-intercept y-intercept occurs when x equal 0. So when x equals 0, function f0 equal 2 times 0 minus 5, 1 minus 0 minus 1, I mean 0 minus 1 squared. Calculate, the result is minus 5. So the coordinate point 0 comma minus 5. 0 comma minus 5. Okay. 1, 2, 3, 4, 5 here. So this is 0 comma minus 5, the intercept point. And after that, the intercept point on x-axis, the x-intercept. It occurs when y equals 0. So it means 2x minus 5, x minus 1 squared equals 0. So x equal 5 half and x equal 1. So there are two coordinate points, 5 half 0 and x and 1, sorry, 1 comma 0. 1 comma 0 is already, and next this is 2 5 half, so it means 3, so 2.5 here. So this is the coordinate point of 5 half, comma 0 that we sketch. Okay, yes, this one. Okay, you can sketch by yourself of your graph like this. Okay, 1, 2. This is 2.5, and this is 2 comma minus 1. Okay, this is the graph. Okay. Next question. Hence find the values of k for which fx equal k has exactly one solution. Okay. So if you look this diagram, this graph, I mean, there are two possible cases where fx equal k has exactly one solution. The first, when when k less than minus 1, k less than minus 1 from this point, okay, 2 downwards on. So look that this graph only intersect at one point. It means it has only one solution, 2 downwards. And after that, when k greater than 0, so you look at this graph only has one solution. After that, this graph it's going to upwards. So we can state that we can state that for uh, for fx, not 4, sorry. that fx equal k has exactly one solution when k less than -1 and k greater than 1. Okay. So only that. Number 3, in these questions, all lengths are in centimeters and all angles are in radians. The diagram shows a circle with center O and radius 12 and a circle with center C and radius 5. The circles intersect at points A and B such that OA and OB are tangents to the circle with center C. Show that the obtuse angle ACB, this angle, ACB is 2.35 radians, correct to 2 decimal places, right? When I change comes black, right? So look that OC actually here. OC actually, this is a right angle triangle, okay, with hypotenuse OC. So OC equals square root of 12 squared plus 5 squared, 144 plus 25, square root 169, and the result is 13. Okay, and after that, we're going to find this angle OCA, angle OCA. For angle OCA, we want to find the tangent, okay, tangent OCA, so here, tangent OCA, angle OCA, tangent angle OCA is 12 over 5. Okay, so it means angle OCA is arctangent or tangent power -1 of 12 over 5, and it is 1.176 radians. So it means angle ACB equal 2 times angle OCA, 2 times 1.176. It is 2.352 or 2.35 radians. Right. So it means we can state that angle ACB equal 2.5 radians. Find the perimeter of shaded region. So we're going to find first this arc, okay, and the sector area ACB, and after that, this area, and we're going to find this, the perimeter, sorry, the arc. I mean, we are going to find the arc AB, and after that, OA plus OB plus arc AB. So we need to find arc AB first. Arc AB equal arc times angle ACB. It is 5, radius is 5 times 2.35 equal 11.75 centimeters. So it means perimeter equal 12 plus 12 plus 11.75, and it is 35.75 centimeters, or round off becomes 35.8 centimeters. C, find the area of shaded region. Okay, so we need to find the area, the sector area first. The sector area equal 1/2 times r squared times theta. Theta is angle. So 1/2 times 5 squared times angle. ACB is 2.35. And if you calculate, the result is 1/2 times 25 times 2.35 is 29.375 centimeters squared. And after that, I will calculate OAC area. OAC. OAC, this area. Okay. OAC area OAC equal 1/2 times 5 times 12, 30 centimeters squared. And after that, area OACB. Area OACB is 2 times area OAC. So it becomes 2 times 30 centimeters squared. It is 16 centimeters squared. So the shaded region, area of the shaded region equal area OACB minus the sector area. 60 centimeters squared minus 29.375 centimeters squared equal 30.625 centimeters squared. 30.6 centimeters squared. Number 4, the function f is such that fx equal 4 ln 3x minus 2 for x greater than a, where a is as small as possible. Write down the value of a. The value of this one, ln 3x minus 2, is positive, always positive, because ln, the value of ln always positive. So it means we can state that 3x minus 2 always positive. So it means 3x greater than 2 and x greater than 2/3. Based on this information, we can state that a equals 2/3. Write down the range of f, range of this function. The natural logarithm of function 1 ln 3x minus 2 always positive based on this information. So for 3x minus 2 greater than 0, the range are from minus infinity to infinity, so on. Or the range of f are all of real number. 3, find the inverse, the f inverse, starting its domain and range. Right, so y equal 4 ln 3x minus 2. So it becomes 1/4 y equal ln x minus 2, or it becomes e power minus, e power, not minus, sorry, e power 1 quarter, e power 1 quarter y equal 3x minus 2, or 3x equal e to the power 1 quarter y plus 2. So x equal 1/3 e to the power 1 quarter y plus 2. Now, regarding domain of f inverse are minus infinity to infinity, same with range of fx or r. This is the domain of this one, f inverse, and the range of f inverse is same with the domain of f, and the range is greater than 2/3. On the axis, sketch the graph of y equal fx and f inverse, stating the intercept with the x. Okay, so I would like to sketch first the graph of y equal 4 ln x minus 2. One. So first find the intercept on x-axis. Set y equals 0. If y equals 0, it becomes 4 ln 3x minus 2 equals 0. So ln 3x minus 2 equals 0. 0 is ln 1. So 3x minus 2 equal 1, and 3x equal 3, so x equal 1. Okay, so it means the coordinate point 1, 0. And after that, set x equal 0. For y-intercept, x equals 0, so y equal 4 ln 3 times 0 minus 2. So there is no result for this one because ln minus, so there is no intercept for this one. And the next is, I would like to determine the asymptote. The logarithmic function has a vertical asymptote where the argument equals 0, or the argument is this one, 3x minus 2, if this equals 0, argument equals 0. So x equal 2/3. Okay, is this one here? Okay, and 2/3 around here. So this is the asymptote. Okay. Actually, this is a straight line. Okay. And after that, for graph f inverse, okay, for f inverse, I would like to find the y-intercept. Y-intercept, set x equals 0. If x equals 0, it becomes e to the power 0 quarter plus 2, over 3, and it is 3 over 3, it is 1. So the coordinate point 0, comma 1. Okay, 0, comma 1. There's another 1, comma 0. So 1, comma 0 and 0, comma 0, 0, comma 1 around here. And after that, we're gonna find for x-intercept, there is no result, so there is no x-intercept horizontally asymptote. For horizontal asymptote, it occurs when e to the power x over 4 equals 0. So y equal 0 plus 2 over 3. This is 2/3. The asymptote, 1, 2/3, 2/3 around here. So it's going to be like this. Okay. So let's sketch. And for fx, okay, for fx, like this, it's through 1, 0 fx. It becomes like this. Okay, and then for f inverse is here. Okay. This is the graph. This is the graph of f inverse, and this is the graph of fx. Next question. Given that gx equal to x plus 1 power 1/2 plus 4 fx for x greater than 0, solve the equation gx equal 9. Okay, let y equal square root 2x plus 1 plus 4. So it means g of gx equal g of y, and it equal 9. So gy equals square root 2y plus 1 plus 4, and it equal 9. So square root 2y plus 1 equal 5, because 9 minus 4. So 2y plus 1 equal 25. Y equal 24, and y equal 12. Y equal 12, substitute into this information. Square root 2x plus 1 plus 4 equal 12. Or square root 2x plus 1 equal 12 minus 4, 8. Or 2x plus 1 equals 64. So 2x equals 63, because 64 divided 64 minus 1. So x equal 63 half, or in decimal number to 1.5. That's one. Number 5, show that 1 plus cotangent square theta over cotangent square theta equals secant square theta. 1 plus cotangent square theta, it is cosecant square theta. So this expression we can writing as cosecant square theta over cotangent squared theta, this expression. So it becomes 1 over sine squared theta, because cosecant squared theta equal 1 over sine squared theta. It is cosecant squared theta over sine squared theta. Okay, so it becomes 1 over sine squared theta times sine squared theta over cosine squared theta. Divided equal 1, it is 1 over cosine squared theta. And it is secant squared theta. So same with this one. Next question. Write down the derivative of tangent theta with respect to theta. Okay. dd theta of tangent theta equals secant squared theta. Using part A and part B, find the exact value of this integral. So this integral, I would like to writing as integral, especially for this part, for this term, according to part A, that is secant squared theta minus sine theta d theta. So it means I'm going to find so this integrand becomes this one, and after that I will find the integral of this integrand. The integral of this integrand is tangent theta plus cosine theta, because minus sine becomes minus cosine, so becomes plus cosine here. After that, substitute pi third and 0. You substitute, becomes tangent pi third plus cosine pi third minus tangent 0 plus cosine 0. It is square root 3 plus 1 half. 0 plus 1. Square root 3 plus 1 half minus 1, because it's minus 1, equals square root 3 minus 1 half. Next question. Number 6a. Find in descending powers of x the first three terms in the expansion of x plus 2 over x squared power 10. Simplify each term as far as possible. The general form, the general term of the binomial expansions of a plus b power n, for this case, I would like to writing like this: tk plus 1 equal combination 10k times x power 10 minus k times 2 over x squared, based on this information. Okay, so it becomes the combination 10k 2 power k times x power 10 minus k minus 2k, because 2 times k. So it's going to be the combination 10k of 2 power k times x power 10 minus 3k. So this is tk plus 1. Now for k equals 0, for k equals 0, t1, because k equals 0, so it becomes t1. t1 is combination 10, 0 of 2 power 0 of x to the power 10 minus 0. becomes 1, so 1 times 1 times x power 10 becomes x power 10. Next, for k equal 1, so it means t2 because 1 plus 1. The combination 10, 1, 2 power 1 times x power 10 minus 3. So it becomes 10 times 2 times x power 7 becomes 20, 20x power 7. 4, k equal 2, t3, c, the combination, then 2 squared times x power 10 minus 6. So it is 45 times 4 times x power 4 becomes 180x to the power 4. So the first three terms in the descending powers of x are x power 10 plus 20x power 7 plus 180x to the power 4. Find the term independent of x in the expansions of for x squared plus 1 over to x squared plus 8. We use the binomial expansion tk plus 1 equal the combination ak for x squared 8 minus k times 1 over 2x squared power k. So it becomes the combination ak 4 power 8 minus k times x to the power 2 times 8 minus k times 1 over 2 power k times x power 2k because 1 power k is 1. So it's going to be combination a k c a k is a combination times 4 power 8 minus k over 2 power k times x squared times 8 minus k minus 2k becomes c or combination 8k times 4 power 8 minus k over 2 power k times x power 16 because 2 times 8 minus 4k because 2 times k 2 times minus k is minus 2k, minus 2k becomes minus 4k. Next. To find the term independent of x, we have to set the exponent equal 0. This exponent of x, I mean, okay? And this is the coefficients of x. So the exponent of x equals 0. It means 16 minus 4k equal 0. So 4k equal 16 and k equal 4. And after that, we are going to compute the coefficient of x, or f x power 4. So P5 equal the combination x 4, 4 power 4, 2 power 4 equal, this is 70 times 256 over 16 equal 70 times 16. The result is 1121. Number 7. It is given that y equal learn 3x squared minus 1 over x plus 2 for x greater than 1 over square root 3. When x equal 1, y is increasing at the rate of h units per second. Find in terms of h the corresponding rate of change in x, giving your answer in exact form. Okay. So the first step, I would like to find dy dt. Okay. So it means I will be using the substitution, let u equal learn 3x squared minus 1. So it means du dt equals 6x over 3x squared minus 1 dx dt. And, and phi equal x plus 2. So the phi dt equal 1 dx dt. Now substitute into here dy dt, it becomes, I will using, as usual, we use x plus 2 phi du dt, sorry, 6x first, 6x over the x squared minus 1 dx dt. So that minus ln 3x squared minus 1 dx dt. Okay. And it becomes, I would like to factorize x plus 2 times 6x over 3x squared minus 1 minus, this is divided, so they divided phi squared actually. Divided the phi squared. So divided by phi squared becomes divided this one, x plus 2 squared. And after that factorize, x plus 2 times 6x over 3x squared minus 1 minus ln the x squared minus 1 over x plus 2 squared. So factorize dx dt. And the next step, when x equal 1, okay, when x equal 1, based on the information, when x equal 1, dy dt, okay, dy dt equal h, okay, based on the information on the question. So we can substitute x equal 1 here and dy dt here. So it becomes, dy dt, I will write here. So becomes 1 plus 2. 3 times this is 6 over this is, yeah, this is 3 also. Okay. Minus ln, ln, this is ln 2. Okay. Over 9. Okay. Dx dt equal h based on this information. So it's going to be 9 minus ln 2 over 9 dx dt equal h. So dx dt equal 9h over 9 minus ln 2. So this is dx dt. Number 8. The tangent to the curve y equal e power x to x plus 5 power 1 half at the point where x equal 2 meets the x-axis at the point x and the y-axis at the point y. Find the coordinates of the midpoint of xy, giving your answer in exact form. Okay, y equal this one, and when x equal 2, it means y equal, substitute x into here, e squared becomes square root 4 plus 5. 9, so 3e squared. So this is y when x equal 2. So the coordinate point becomes 2, 3e squared. And after that, differentiate this function, this equation. Okay, let u equal e power x, v equal 2x plus 5 for 1 half. So du dx e power x and the v dx 1 half times 2x plus 5 power minus 1 half. So it becomes times 2 because differential of 2x. So 2 times 1 half is 1. It becomes 1 over the root 2x plus 5. So it means dy dx equal e to the power x times 2x plus 5 plus e power x times 1 over the root 2x plus 5. And after that, factorize e to the power x, 2x plus 5 plus 1 over the root 2x plus 5. So when x equal to, and x equal to dy dx becomes e squared times the root 9 plus 1 over square root 9. It is e squared times 3 plus 1 third, 10 thirds. So it becomes 10 third e squared. So this is the gradient. So gradient 10 third e squared. And the next step, we're gonna find the equation through 2, 3 e squared using this formula y minus y1 equal n times x minus x1, x1, y1. So this equation becomes y minus 3e squared equal n, this one, squared, x minus 2, like this. So it means I would like to, find first times x 20 over 3e squared, like this. And after that, the equation becomes 10 third e squared x minus 20 third e squared plus 3e squared. So y equal 10 third e squared x minus 11 third e squared. 11 because this is 9. 9 plus minus 20 is minus 11. So this is y. And after that, we're going to find the x-intercept. The x-intercept when y x-intercept when y equal 0. And if y equals 0, this equation becomes 10 third e squared. X minus 11 third e squared equals 0. So 10 third e squared x equal 11 third e squared. E squared divided by e squared equal 1. So x equal 11 third times 3 over 10 is 11 over 10. So the coordinate point 11 over 10, comma 0. And after that, we're going to find the y-intercept. Y-intercept when x equals 0. Set x equals 0. When x equals 0, becomes y equals 10 third e squared times 0 minus 11 third e squared. So y equal minus 11 third e squared. So the coordinate point 0, comma minus 11 third e squared. And after that, midpoint. The midpoint xy is 11 over 10 plus 0 over 2 and 0 plus minus 11 third e squared divided by 2. So it becomes 11 over 20, comma, minus 11 over 6 e squared. This is the midpoint. Number 9. Look this graph. The question based on this graph. The diagram shows part of the curve y equal 4 over 2x plus 1 and the straight line to y equals 6x minus 6x plus 1. So this is the straight line and this is the curve of y equal 4 over 2x plus 1. Find the area of the shaded region, giving your answer in the form learn a plus b, where a is an integer and b is a rational number. So we're going to find this shaded region. So the first step, we need to find this intersection point, and after that, we're going to use the integral from this point from 0, this is 0, to this point in x-axis. Okay, right. Now substitute this information y equal 4 over 2x plus 1 into this equation. So if you substitute y into this equation, it becomes 2 times 4 over 2x plus 1 equals 6x plus 1. Okay, so 2 times 4 equal 8 over 2x plus 1 equals 6x plus 1. After that, multiply by 2x plus 1. Left hand side, right hand side, multiply by 2x plus 1. So it's going to be 8 equal 2x times 6x, 12x squared plus 6x plus 2x plus 1. So it becomes 12x squared plus 8x minus 7 equals 0 because 1 minus 8. Now, I would like to factorize this expression becomes 2x plus 1 and 6x plus 7 equals 0. So it means 2x equal 1 or 6x equal minus 7. So x equal 1 half and x equal minus 7 over 6. But we just accept this solution because for x negative, impossible, because if you look this intersection, it occurs on positive area, this x positive area, not in negative area. So it means we just accept x equal 1 half. So this is 1 half here. This is 1 half on x-axis. Now we're going to find the coordinate point on y-axis. How much this one? Let's define. Substitute x equal 1 half into 2y equals 6x plus 1. It's going to be 2y equals 6 times 1 half plus 1. So 2y equal, this is 3 plus 1, 4. So y equal 4 halves. It is 2. So the coordinate point, the intersection coordinate point on 1 half comma 2. So this is 2 on y-axis. And this coordinate point is 1 half comma 2. It means the integral area from 0 to 1 half of 4 over 2x plus 1 minus 3x plus 1 half dx. Now I would like to find one by one. I separate this integral 0 to 1 half. The integrand is 4 over 2x plus 1 dx plus 1. 0 to 1 half. The integrand is 3x half dx. Okay, now this integral, for integral 0 to 1 half, the integrand is 4 over 2x plus 1 dx. Let u equal 2x plus 1. So du equal 2 dx. It means 1 half du equal dx. And when x equal 0, this one, when x equals 0, u equal, based on this information, u equal 2 times 0 plus 1 equal 1. So 0 becomes 1. And when x equal 1 half, u equal 2 times 1 half plus 1. So it is 1 plus 1 equal 2. So the integral from 0 to 1 half becomes 1, integral 1 to 2. 1 to 2. And 4 over 4 over u 1 half du. This, so it becomes 4. 4 divided by 2 equal 2. 2 integral 1 to 2 du over u. And it is 2 integral to 1 to 2. And the integral of these expressions is ln u. So it becomes 2 ln 2 minus ln 1, or 2 ln 2 divided by 1. It means ln 2. So it is 2 ln 2. This is the result of this integral. And the second integral is integral 0 to 1 half of 3x plus 12, or plus 1 half dx. 0 to 1 half. And the integral of this integrand, the integral of this integrand is 3 half x squared plus 1 half x. After that, substitute 1 half and 0 into this expression and becomes 3 half of 1 half squared. 1 half times 1 half minus 3 half times 0 squared. 1 half times 0. This is 1 quarter times 3 half equal 3 over 8 plus 1 quarter minus 0. It becomes 3 over 8 plus 2 over 8, 5 over 8. So it means the integral area, the area, this area of the shaded region, integral 0 to 1 half of 4 over 2x plus 1 minus 3x plus 1 half dx is equal to ln 2 minus 5 over 8, or ln 2 squared minus 5 over 8, or ln 4 minus 5 over 8. This is the area. Next question. 10. The first three terms of an arithmetic progression are 2 tangent to x, 5 tangent to x, 8 tangent to x. Find the failures of x, where x interval minus 180 to 180, for which the sum of 30 terms, is 455 square root 3. Okay, so this is arithmetic progression. So I'm going to find the common difference. The common difference can find through 5 tangent to x minus 2 tangent to x. 5 tangent to x minus 2 tangent to x equal 3 tangent to x. So this is the common difference of this arithmetic progression. Now, based on this information, sum to 30 terms, it means S30 equal 30 half times 2 to A, it means 2 tangent to x, it's 1, plus 30 minus 1 times common difference, 3 tangent to x. So it becomes 15 times 4 tangent to x. This is 29 times 3, 87 tangent to x. It becomes 15 times 4 plus 87, it means 91. So 15 times 91 tangent to x. If you calculate, the result is 1365 tangent to x. After that, set this equal to the given value. Based on this information, it is equal 455 square root 3. Okay, so it means tangent to x equal 455 square root 3 over 1365. So it means tangent to x equals square root 3 over 3, square root 3 third. So tangent to x equal tangent 30 because square root 3 third is tangent 30. So it means can state that 2x equal 30 plus 180 times n because square root 3 third not only in the first quadrant but in several in next quadrant also. Okay, let's we check one by one. When n equal minus 2, x equal, it is x divided by 2, 15 plus 90 times n, because divided by 2 equal 15, divided by 2 equal 90. So x equal, this is 15 plus 90 times minus 2. This is minus 180. Minus 180 plus 15 is minus 165. Okay, and recall that the x interval minus 180 to 180. This is the interval, so accept this solution. N equal minus 3. Okay, yes. X minus 3, it means 15. Sorry, minus 1. But if minus 3 under the 180, this 1. 1. So this becomes 90 minus 15. 90 minus 15 minus 75. Okay, accept. N equals 0. So x equals 15 plus 90 times 0. It is 15. 15 plus 90 times 0. 15. N equal 1. 15 plus 90 times 1. 105. Okay. N equal 2. 15 plus 90 times 2. 180 plus 15, 195 greater than 180, greater than this one. So the solution is only this one, minus 165, minus 100, minus 1, minus 75, minus 15, and 105. So the values of x, the valid values of x are minus 165, minus 75, 15, and 105. Next question. The first three terms of a geometric progression, now geometric progression, just now arithmetic progression. Okay. This one, 5 cosine squared theta minus pi half, 20 cosine of 4 theta minus pi half, 80 cosine power 6 theta minus pi half, where theta interval minus pi over 6 to 7 pi over 6. Find the values of theta for which this geometric progression has a sum to infinity. Yeah. We need to find the common ratio first. The common ratio, or R, equal T2 minus T2 over T1. T2 is this one. Okay, 20 cosine power 4 of theta minus pi half over 5 cosine squared theta minus pi half. So 20 divided by 5 is 4 cosine squared theta minus pi half. So, and after that, for a geometric progression to have a sum to infinity, the common ratio must satisfy modulus R less than 1. So I would like to writing that, so this is 4, not 5, 4, that 4 cosine squared, modulus cosine squared theta minus pi half, the modulus, less than 1. And the value of cosine squared theta minus pi half is always positive. So we can writing that cosine squared theta minus pi half is less than 1/4, because divided by 4. So cosine theta minus pi half, because it's squared, okay, it becomes modulus square root of 1/4 equal 1/2. Okay, but 1. Now let's phi equal theta minus pi half. So it means theta equal phi plus pi half. So cosine phi from this one less than 1/2. If you compare with the cosine graph, okay, I would like to find here sine graph. Okay, y says x. Okay, this 1, the maximum is 1, and minimum is -1. And cosine, this is 1/2 pi, and this is pi. Okay, so the graph like this, Okay. So this is, here is pi third, and here is 2 pi third. Okay. So cosine phi, modulus cosine phi less than 1/2. Okay, uh, when the interval, okay, okay, so we can find the value of cosine phi less than 1/2. It occurs when phi interval greater than pi third, this one, pi third, and less than 2 pi third. If you check the value of cosine phi less than 1/2 occurs on this interval. Okay. Actually with uh, actually for with phi greater than 4 pi third, less than 5 pi third. But this interval out of range, because the range from minus 180 to 180. This is the range. Okay. Yeah. The range is 180 to minus 180 to 180. So it means if we convert if we convert back to theta equal phi plus pi half, like this, the intervals becomes theta greater than pi third plus pi half, less than 2 pi third plus pi half. If we calculate, it becomes pi over 6, 5 over 6 pi, theta greater than 5 over 6 pi, less than 7 over 6 pi. This is interval of theta.